Welcome back to ChemExam Explained, where the aim is chemistry clarity, exam mastery. In today's video, we will be looking at Cape Chemistry Unit 1, 2023, Module 3, Chemistry of the Elements. Number 3. Table 3 shows the formulae and oxidation numbers of the elements of period 3. We are required to complete the table. A Part 1. Write the formulae for the oxides of the elements in period 3, excluding chlorine and argon. That is why those areas are shaded. Part 2. Write the oxidation number for each element of each oxide in period 3, excluding chlorine and argon. So for sodium, we have sodium oxide. For magnesium, we have magnesium oxide. For aluminum, we have aluminum oxide. For silicon, we have silicon dioxide or silica. For phosphorus, we have phosphorus pentoxide. For sulfur, we have sulfur trioxide. Now for the oxidation numbers of the elements, once we know the formulae, we can actually work out the oxidation numbers for each of the compounds. So let's start with sodium. So that's Na2O. From the rules, we're trying to find out what Na is. We know that oxygen is always -2 except when it is a peroxide. So let's go with 2x plus -2 equal 0. 2x minus 2 equals 0. 2x is equal to plus 2. X is equal to plus 2 divided by 2, which gives us plus 1. That is the oxidation number for sodium in sodium oxide. Let's work out magnesium oxide, MgO, and we're finding Mg. So that's X plus -2 equals 0. X minus 2 equals 0. X is equal to plus 2. So as you can see, as we go across the period, the oxidation number is increasing from +1 to +2. Let's do aluminum oxide. Al2O3. So remember that the rule is that the sum of the charges in the compound, they're equal to 0. So here, we're trying to find aluminum. So it's 2x plus 3 times minus 2 equals 0. 2x minus 6 equals 0. 2x equal plus 6. X equal plus 6 divided by 2 equal plus 3. For silica or silicon dioxide, it is SiO2. We're trying to find for Si. So it's X plus 2 times -2 equals 0. X minus 4 equals 0. X is equal to plus 4. So the oxidation number of the element silicon is plus 4. Let's do phosphorus pentoxide, P4O10. So that's 4x plus 10 times minus 2 equal 0. 4x minus 20 equals 0. 4x equal plus 20. X equal plus 20 divided by 4. X is equal to plus 5. Hence, phosphorus pentoxide. Finally, let's do SO3. SO3, let's find S. So X plus 3 times minus 2 equal 0. X minus 6 equal 0. X equal plus 6. So we actually calculated the oxidation number of each of the elements of the oxides in period 3. And as you can see, the oxidation number increased. So part 3 is asking us to explain the nature and the variation of the oxidation numbers for the elements in the oxides in table 3. The oxidation number of the elements in the oxides of period 3 exists as positive numbers because oxygen is more electronegative than the elements. The oxidation number increases from +1 to +6 because of the ability of the elements to use all their outermost electrons in bonding. Part B, write the equation for the reaction between the oxide of phosphorus and cold water. So phosphorus pentoxide plus water produces phosphoric acid. And of course, you balance the equation and place in the correct state symbols. Part C, describe using equations the acid-base behavior of the oxide of aluminum. Now, we should know that the oxide of aluminum is amphoteric, which means that it has both acidic and basic character. All that is saying is that aluminum oxide can behave as an acid as well as it can behave as a base. So we're now going to write equations with that in mind. So if aluminum oxide is acting or behaving as a base, then it will react with acid to form salt and water. So we have Al2O3 plus hydrochloric acid to give us aluminum chloride plus water. Now, if aluminum oxide is behaving as an acid, then it will react with a base, form salt and water. So in this case, aluminum oxide is behaving as an acid. It is reacting with a base, sodium hydroxide, to form sodium aluminate plus water. So acid plus base forms a salt and water. Part D. State one use of the oxide of aluminum or the oxide of phosphorus. The oxide of aluminum acts as abrasive, ceramics, aluminum pots, and pans. The oxide of phosphorus acts as a drying agent. Part E. Consider the halogens chlorine, bromine, and iodine. Part 1. State the colors of all the halogens. So chlorine would be yellow-green, bromine would be reddish-brown, iodine would be black in appearance. So it is really a purple solid, but because of the compact nature, it is black in appearance. Part 2. State the trend in volatility of the elements. So when we look at volatility, it is linked to boiling point. So the lower the boiling point, the more volatile the element. So looking at this particular list, chlorine, bromine, iodine, we're going from gas to liquid to solid. Therefore, volatility decreases going from chlorine to iodine. Part 3. Account for this trend in volatility in terms of atomic size and intermolecular bonding. So going down the group from chlorine to iodine, 1. An additional shell is added each time. 2. This causes the atomic size to increase going down the group. 3. As atomic size increases, van der Waals and dipole-dipole forces get stronger, which decreases volatility. So we're saying that going down the group, if you have 2 shells here, then you'd now increase to 3. And then you'd increase to 4. Just an example. Okay? And so you see atomic radius increases down the group, right? So the atomic radius is getting larger, and the force of attraction between the molecules are stronger because, of course, we're going from gas to solid. Part F. When bromine is added to cold aqueous sodium hydroxide, bromine is decolorized, leaving a colorless solution. The equation below represents this disproportionation reaction. When the colorless solution has excess silver ion added to it, a suspension is formed, which is filtered. On heating the colorless filtrate, a cream precipitate is formed. Use the equation to explain the term disproportionation. Now, the first thing I must say is that once you hear this term or see the term disproportionation, then the same species that is oxidized is the same species that will be reduced in the same equation. So bromine with an oxidation number of 0, because it is an element in its free state, so it's 0, it is reduced to bromide ion. So we have Br2, 0, going to Br minus. So this is reduction. But the same species, bromine, which is 0 here, is now being oxidized to bromate ion. And that gives us a charge of +1. So the same species that was reduced is the same species that is being oxidized. So it takes place simultaneously. And that is the meaning of disproportionation. Part G. Study table 4 of the electrode potential values and answer the question. Which of the halogens bring about the maximum change in oxidation number of sulfur? So examining the table, we see where we are given electrode potential values for some half equations. Now we must know that the more positive the electrode potential values, then the stronger of an oxidizing agent the elements will be. So in this case, chlorine would be the strongest oxidizing agent, and therefore it will bring about the maximum change in oxidation number of sulfur. Let me say that in the event you get negative values or less positive values, then it would be stronger reducing agents. So the more negative the electrode potential value, the stronger of a reducing agent the species will be. The more positive the electrode potential, the stronger of an oxidizing agent the species are. So that is why chlorine is the one that will bring about the maximum change. Now they want us to write a full ionic equation to represent this change. Now, I think this is unfair for just 1 mark because you must combine 2 half equations and then simplify it. So we are combining Cl2 plus 2 electrons to 2Cl minus, as well as we are combining S2O3 2 minus plus 5H2O to give us 2SO4 2 minus plus 10H plus 8 electrons. So we have the 2 half equations. Now let me say this. When you look at these 2 equations, we're focusing on this one and we're focusing on this one. So this one is the stronger oxidizing agent. Now, if you are an oxidizing agent, it means that you are being reduced. So electrons on the left-hand side of the arrow is suggesting reduction. Now, the more negative the value, then you are now a stronger reducing agent, which means that if you are a reducing agent, then you are oxidized, which means that the electrons must be on the right-hand side of the equation. So what we do is we keep the Cl2 with the electrons on the left-hand side, but for this equation, we must flip it. Now, when we flip it, we'll get electrons on the right-hand side, suggesting oxidation. So reduction is taking place in this one, and oxidation is now taking place in this one. Once we flip, we must sum the two equations. Now, in order to sum them, the electrons must be equal. So we're going to multiply equation 1 by 8 to get 16. And then we're going to multiply equation 2 by 2. So equation 1 is this one. And this is equation 2. So when we multiply equation 1 by 8, we get 16 electrons, and we multiply right throughout. When we multiply equation 2 by 2, we get 16 electrons. So once we have the electrons being equal, we are now going to sum the equations. So we have 8Cl2 plus 8 times 2 electrons, 16 electrons, plus 2 times S2O3 to give us 2S2O3, plus 2 times 5H2O to give us 10H2O. Then we go to the right-hand side. So 8 times 2 give us 16Cl minus, plus 2 times 2 give us 4SO42 minus, plus 2 times 10 give us 20H plus 16 electrons. So we have 16 electrons on both sides, so it can be eliminated. After which, we're going to simplify the equation. So 2 into 8 goes 4 times, so 4Cl2 plus 2 into 2 give me 1S2O3 plus 2 into 10H2O produces 5H2O. 2 into 16Cl minus give us 8Cl minus. 2 into 4SO42 minus give us 2SO42 minus. 2 into 20H plus give us 10H plus. And if you work out the oxidation numbers on the sulfur on the left-hand side of the equation and the sulfur on the right-hand side of the equation, you'll see that the oxidation number increased from +2 to +6. And that would be the maximum change in oxidation number of sulfur. Part H. NaZ is a sodium halide which gives the following results on testing. Let's look at the first observation. Bubbling chlorine into an aqueous solution of NaZ gives a brown solution. On addition of starch, a blue-black color forms. The other observation is addition of silver nitrate to NaZ gives a yellow precipitate which is insoluble in aqueous ammonia. Part I. Identify element Z. Now, if you look at the first observation, chlorine is above Z in group 7. That is why it is able to displace it. So chlorine being a stronger oxidizing agent than Z, which represents iodine in this case, it will displace it, and iodide ion, which was in the salt, now forms iodine solution. It is a brown solution. Now, to confirm that it is iodine, the starch is added, which gives a blue-black color. And that confirms that the element Z is iodine. Part 2. Explain the reaction taking place in each of the tests above. Include balance equations in your explanation. Now, you recall me saying that chlorine displaces iodine from its salt. So chlorine would react with NaI to produce NaCl plus aqueous iodine. Or you could write the ionic equation by saying Cl2 gas plus 2I minus produces 2Cl minus plus aqueous I2. Now, when aqueous silver nitrate was added to the sodium iodide, which was NaZ, it gives a yellow precipitate, and that yellow precipitate is silver iodide. silver iodide is insoluble in aqueous ammonia. And this would be the molecular equation and then the ionic equation. So let's talk about if it was chlorine with silver nitrate. So chlorine with silver nitrate gives a white precipitate of silver chloride. Now that precipitate will dissolve in excess aqueous ammonia. If it was bromine, silver nitrate would form silver bromide, which is a cream or off-white precipitate, which is partially soluble in aqueous ammonia. But silver, when combined with iodine, forms silver iodide, which will not dissolve in aqueous ammonia. Hence, you form that yellow precipitate. So you can see that in the molecular equation, and you can also see the ionic equation, where the spectator ions were removed. This is the end of Module 3, Unit 1, 2023. Please remember to like and subscribe. This will help the channel to grow. Thank you.